Today we're going to be looking at arithmetic sequence and series. So an arithmetic sequence is basically a sequence of numbers, for example 4, 7, 10, that have the same common difference. These dots here represent that the sequence goes on with the same pattern. So if it's an arithmetic sequence, it'll have the same difference between each two terms. So for example, 7 to 10 has 3 as a difference. 4 to 7 also has 3 as a difference. So the difference is 3. We represent this with the D. The D is 3. So what about this pattern? Is this an arithmetic sequence? Well, the difference here is 5. The difference here is 10. It's not an arithmetic sequence. It is in fact a geometric sequence, but we're not going to be covering that today. So we can remove this. There's a formula to find the difference. It's very simple. You have U, N. Now U, for me, just represents the arithmetic sequence, and N represents the term in it. So actually U1 will be the first term, U2 will be the second term, which is 7. So UN represents the nth term. Then we have UN minus 1 equals D. Since UN is an nth term, then n minus 1 is the term before it. Say this was U3, that will be 10. Then we subtract that by the term before it, which is 7, and that's U2, that will be D. 10 minus 7 equals 3. This the same as the common difference. So we found a common difference. We can use anything like U2 minus U1, which is more common, or U4 minus U3. Let's say we have a sequence such as 20, 16, 12, 8, and so on, repeats. What is the common difference of this? So we have the difference here. It will be 16 minus 20, which equals -4. So the difference is -4, and we can check if that's true. We can check if that's true here with 12 minus 16, which is also -4. So it repeats, and it goes on so forth, -4. So this is an arithmetic sequence, and the difference can be a negative number. It just means that the sequence shrinks, goes to 0, and then negative. So there are different types of arithmetic sequences. Let's say we go back to 4, 7, 10, and so on. As I said earlier, these dots represented repeats, but repeats forever. So it's an infinite arithmetic sequence. And if you put a number here, like 19, then it's a finite sequence because it ends here. This finite. So let's say we want to find a term in this sequence, the 7th term precisely. How will we find that? Well, there's actually a formula to find that, and that formula is UN equals U1 plus bracket n minus 1 D. So U1 represents the first term of a sequence, which is this 4. So we'll put a 4 here, and then n represents the index of the term that we want to find. And since we want to find the 7th term, we will put 7 minus 1 times the common difference. And we know that the common difference between these is 3. So it'll be times 3. So calculating this, we do 4 plus 6 times 3, which becomes 4 plus 18, and then that becomes 22. So that means u of 7 equals 22. I forgot to replace this with 7. So now let's think about why the equation is like this. Well, if we write out the full sequence until it's 22, be 4, 7, 10, 13, since it's plus 3 is 16, plus 3, 19, and then plus 3, 22. So if we start from the first number, 4, and let me just change the color to blue. First number 4, we add by 3 one time, 2 times, 3, 4, 5, 6 times. It will be added by 3 6 times. So it's just plus 3, plus 3, plus 3, plus 3, plus 3, plus 3. So it'll be a total of 6 times. Whoops, I just wrote that. So that means the difference from the first term, which we know is u1, will be plus the difference 3 6 times. So that's just 6 times 3, and we're getting the 7th term here. There's the 7th term, so it's basically 7 minus 1 will equal 6. 7 minus 1 is 6. That's why the formula is like this: u1 plus n minus 1. So we can actually modify the formula with starting with other terms. So if you do un equals u3, then what will be the remaining formula? Well, we know the third term is here. Then we add 1, 2, 3, 4. 2 plus 3 times 4. So we added 4 times the difference. It's the 7th term. So we do 7 minus 3. Actually, we should just represent this as n minus 3 times d. Notice how this is the same. So you can actually do un equals u5 plus bracket n minus 5 and find any term with this formula, because these are the same, and we've deduced that with this. So now let's talk about an arithmetic series. A series is just the sum of a sequence of numbers. Sum of sequence. So if we go back to our sequence 4, 7, 10, and so on, we want to find the series, which is the sum of the sequence of the first 3 terms. We do 4 plus 7 plus 10. Those are the first 3 terms. That's 4 plus 7 is 11 plus 10 is 21. So it becomes 21. And we write that down as S. S represents the series, the sum of the sequence. S3 specifically to represent the first 3 terms. So there are 2 formulas to find this arithmetic series. There is Sn equals n over 2, 2 times the first term, u1, plus bracket n minus 1 times d. So you can use this to find the sum of a sequence with just the first term and then the position and the common difference. So let's say for this sequence, we want to find the sum of the first 10 terms. We do it so it's S10 equals, and then the first 10 terms will be that, times the first number, the first term, which is 4. So 2 times 4 plus 10 minus 1, which is, and then the common difference, which is 3. 10 minus 1 times 3 will become S 10 equals 5 times 4 times 2 is 8. And then 10 minus 1 is 9 times 3 is 27. So then S10 will be 8 times 5, which is 35, and then 5 times 27. So we know 20 times 5 equals 100. And then 7 times 5 equals 35. We add these together, it will be 135. And then we add that to, oh whoops, 8 times 5 is not 35. That was my mistake. 8 times 5 is 40. Then I got that wrong. But then we'll add this to plus 135. And it'll become 175. So the sum of the first 10 terms is 175. So let's go back to the sequence we had earlier, 4, 7, 10, until 22, which we know is the 7th term. U7 is 22. And same when we find the sum of the first 7 terms in the sequence. So the formula we can use is the one we used earlier, or we can use this new formula, which is a shortcut formula. Sn equals n over 2 u1 plus un, u1 being the first term and un being the nth term of the position we want. So to find the first 7 terms, we do S7 equals 7 over 2, and then that'll be times u1, which is 4, plus 22, which is that nth term, the 7th term, since we're trying to find 7. S7 equals 3.5 times 4 plus 22, that's 26. 26. So to solve this, we can do 26 times 3 will equal, then 20 times 3, 60, and 6 times 3 is 18. So it'll be 60 plus 18, which is 78. Next we do 26 times 0.5, which is basically half of 26, which we know is 13. 78 plus 13 equals 91. So basically, the sum of the first 7 terms in that sequence is equal to 91.